Well, good morning, my algebra students. So we finished 7-2 last week, part 1, as well as 7-1, all talking about greatest common factors, how to factor things that are a greatest common factor. Now we're looking at part 2, factoring out a common binomial. We know that a binomial has two terms and usually has parentheses around it to show that it's a family, right? So let's just review a little bit. If I remind myself what I did last week, I know this term, 7y minus 2ay, the greatest common factor I'd have here would be y, right? Would be y. And I could factor that out. I would put y on the outside, and I would divide it off. And this is what I would get. And I'm undistributing the y, right? Well, now when we talk about a common binomial, we're talking about what if, instead of dividing off y, what if y were a binomial instead? An identical twin, shall we say? So what if y equaled x minus 3? Well, then this equation, 7y minus 2ay, would look like this instead. It would be 7, and instead of y, it would be x minus 3 minus 2a and times x minus 3, right? It's the same thing, but instead of y, y is now represented by x minus 3. So can we factor that off just like we factored the greatest common factor of y off? Well, yes, we can, right? So we can divide off the x minus 3 just like we divided off the y. So that's going to go on the outside just like I did with y. And I just factored them off. Right? So what's left over, right? I'm dividing off this. So left over is still the 7 minus 2a, right? Okay, let's take a peek at this one. Could we divide something off? What would be the greatest common factor? Well, don't forget there's a 1 right there, right? So could I divide off that like term of t squared plus 4? Well, yes, I can. That is my greatest common factor. So I divide that off, and I find out what's left. Negative t plus 1. Let's look at it again. If I have x squared times x plus 1 plus 2 times x plus 1, well, then I have the greatest common factor of x minus 1. So if I divide that off, I end up with x squared plus 2. How about this one? This appears to maybe not look right. But if I rewrite it in standard form, well, it is the same, right? That's, again, why we want to put things in standard form. It just makes our life so much easier. And I'm going to go ahead and divide off the greatest common factor of x plus 4. So I'll have 9x minus 5 and x plus 4. Now, if I wanted to multiply that and see if I could get that, I'm sure I could. You try. Give it a whirl, pause the video here, and see how well you can use your greatest common factor as a binomial. Hopefully this is what you got. Okay, so So now let's talk about the next step of factoring by grouping. Are you kind of seeing why I broke this lesson into two pieces? Well, factoring by grouping is if I have 4 terms. My first step is I want to look at how I can separate them, because none of these have a greatest common factor, right? I think, oh, maybe 3, but 20 kind of throws that off. And, oh, maybe A, but no, 15 doesn't have an A. So they have no greatest common factor together. But if I make them into 2 separate families, I can then find a GCF in each. So if I divide off a 3A squared here, I end up with 4A minus 3. And coincidentally, if I divide off a 5 over here, I end up with a 4A minus 3. And what do you know? We now have another greatest common factor, and we can factor that off. And we end up with this nice little binomial pair. Let's take a look at that again. If I have 4 terms, now I can even change the order of these. It wouldn't really matter, but I'm going to keep them in the order that they're in because they are in standard form, so that helps me. And I'm going to group them, making them 2 sets of binomials. And I'm going to factor out a greatest common factor. Here, I have 9x squared, which leaves me with, of course, x plus 2. And that's added to 1 times x plus 2. So now I can factor out that greatest common factor of x plus 2. And it leaves me with x plus 2 times 9x squared plus 1. Now, again, I could always check this, like I said before, if I want to re-multiply it out, if I used box to do that. And you'll see if I have 9x squared plus 1 and x 2, I end up with 9x to the 3rd power, 18x squared, and x, and 2. And when I combine my like terms, I end up with 9x to the 3rd power plus 18x squared plus x plus 2. And it gets me all the way back to the beginning. So I know I did it right. Let's go ahead and factor when it has to do with opposites. We're going to look at the same idea, but just seeing that we might have some different scenarios, right? So here, I'm going to rewrite them so they're in standard form first. Then I'm going to group it. Notice that this says subtracting here, but I don't want to have to be applying a subtraction to here and here. I need to be careful of that. So instead, I'm going to make this addition, and I'm going to tuck inside the parentheses to make that -2 stay with -2x. Now I'll factor off a greatest common factor on both sides. And we see that now we have a common binomial. And voila. Let's take another practice time to do it. You can pause your video here, give it a whirl, and see how you do. Okay, just checking. Did you tuck that -2 and that negative sign in with that 2? I hope so. Now I take out a greatest common factor. And I regroup. And it's not factored completely yet. I can take a 2 out of that first term. And now it's factored completely. Go ahead and try this. Hopefully this is what you got. We started with factoring right here, grouping, taking a GCF off, and then regrouping. Okay, here is 2 more U tries. I just want to make sure we review these all the way. Number 1, we're taking a greatest common factor out. Number 2, we're factoring a common binomial out. And then, of course, now we're going to practice factoring by grouping. We make our groups, take a GCF out, factor out the common binomial, and there you have it. Okay, today you have 7-2 Part 2 puzzle. Part 2. And you have some textbook problems right here. Keep up the good work.